Hi, it's time for another M1 question. This is a ships colliding question. I do love these. Not necessarily about ships colliding, but the actual scenario and what's involved. So it's a vectors, and here's part A and B of the question. The rest of it is to follow. You can either pause, have a go at the question yourself, and then watch me go through it with you, or you can just play the video and see how it's done, okay? You choose, okay, it's up to you. Anyway, 12 o'clock, a ship P sets sail from harbour with position vector 15i plus 36j kilometres. 12:30, P is at the point with position vector 20i plus 34j kilometres. Given that P moves a constant velocity, show that the velocity of P is this. Okay, let's just do that straight away, shall we? So it starts there, ends up there, we've got to find the difference. Now it doesn't show that, so you should show a little bit of working for that. So I'm going to do that by writing down 20i plus 34j. That's where it ends up at 12:30, and subtract from that 15i plus 36j. Because that gives us the difference, you see? The difference between this and this. Like the airplane? Yeah. You can tell I couldn't be doing an airplane question right now. There you go. 34 subtract 36 is negative 2. Okay, so that's that. Okay, and that of course is in 30 minutes from 12 o'clock to 12:30. So I'm going to put there in 30 minutes. All right. Bear in mind it's a show that, so I'm just putting a little bit more work in than I would normally do if it was a find this sort of scenario. That's in 30 minutes. This is in kilometres per hour. Notice, so obviously you double that to get 60 minutes. So I'm going to put so for 60 minutes, making it obvious that it's just double that. We're going to do 2 times 5i minus 2j, and that gives us 10i minus 4j as required. But because it's a show that, I'm going to write down exactly what they put, and then it's obviously kilometres per hour. Okay, and I'm just going to put in there as required, and that's that part of the question done. All right. For part B, so at time t hours after 12 o'clock, the position vector P's P kilometres. Find an expression for P in terms of ij and t. I'm just going to do that up here if you don't mind. Sorry for the messiness, but it's just making use of the board space for the videos. I'm sure you understand. So position vector P. Okay. The way you do this is you first of all consider the initial position vector where it starts, and it starts here. So initially it starts at 15i plus 36j, and then you add to that the velocity vector multiplied by time. Okay, so the velocity vector 10i minus 4j multiplied by time. Okay, it's essentially just where it starts, like here, there, and then it's moving like this, you see, for a certain number of hours. So once you've got the velocity vector, which is essentially giving you the direction it's moving in, it's doing that per hour. So this multiplied by the number of hours, multiplied by t. I'm sure you're happy with that anyway. That will do as an answer. Just bear in mind what's going to come later on about the collisions that I mentioned earlier. I do prefer to give my answer in terms of i's and j's, so that I can both, so 15 plus 10g, so 15 plus 10t, I meant to say, 15 plus 10t, and then plus 36 minus 4 tj. Right, so 15 plus 10ti plus 36 minus 4tj. Okay. Stand by for the next part of the question. Okay, so the next part of the question. So a second ship Q is also travelling, constant velocity. At time t, hours after 12, position vector is given by this. Q is 42 minus 8ti plus 9 plus 14tj. Verify they'll collide at 13:30 as long as they maintain their course. Now they give us a time here, so we can use the value of t. Of course that'll be 1.5. It's 1.5 hours after 12 o'clock, you see, when it starts. So 1.5 is what we use. Now we can just substitute that value into here and into here and show we get the same answer. So I'm going to do that. Okay. So when t equals 1.5, P is equal to, now I'm just going to write down the answer because it's just too obvious. I'll explain what I mean afterwards. Okay, I'm going to write down some working. So 15 plus, that would be 15 I, and then plus 36 minus 6j, so 4 times 1.5, 10 times 1.5, and then that gives me 30i plus 30j, and then do the same for q. Q will be equal to, and here 42 minus, and that's going to be 12, I, and then plus 9 plus, and that will be 21j. Okay, and then simplify that, and that's 30i plus 30j. I think this bit is important because verify they will collide. It's a bit too convenient if you just write down P equals that, Q equals that. Oh look, they're the same. You should show a little bit of work, and I think just to justify that you do get to the same answer. Okay. Then I'm going to put therefore P and Q collide at 1330. Basically, like to show that really, explain that what I said was correct was going to happen. And then I'll go back down the position vector. That covers this part, you see. At 30i plus 30j kilometres. Okay, and that's that part of the question done. Right. Stand by for the final part coming up right now. Okay, last bit, let's go then. So at 12:30, Q changes its speed and direction, of course, to avoid the collision. These things happen in real life, by the way. And you don't know it happens because obviously there's no collision. Okay. Ship Q now travels due north with the constant speed of 15 kilometres per hour. Ship P maintains the same constant velocity throughout. So just bear in mind, if you think about it, both ships don't have to change direction, only one of them does. Just bizarrely, of course, if both ships do change direction, they could still end up colliding, couldn't they? Something like that. You don't really want that to happen. Find the exact distance between P and Q at 2:30. Okay. So remember, 2:30 is where they originally collided, weren't they? So it'd be interesting to see just what the distance actually is between them. So you've got two things going on. You've got P is this and Q is that, but Q changes the speed and direction. Okay. We're going to have to work out where Q is at 12:30. Right. So from this, okay, when let's put it over here, when T equals 0.5. So remember, it was after 12 o'clock. These equations. After 12 o'clock, 12:30, when T equals 0.5, Q is going to be, and we will work out where it is. Okay? So 42 minus, that's 4, so 38, I, and then 9 plus 7j, so that's 16j. Okay, right, that's where Q is after 0.5 hours at 12:30. Okay, then after 12:30. We're going to have to work out what the new expression for the position vector of Q is going to be. All right. So I'm going to label that as Q2. All right. So if I call that Q1, so the original direction heading it was going in, after it changed its course, we'll call it Q2. So like before, you find an initial position vector. So at 12:30, we've decided it's going to be there. And then we're going to add to that the velocity vector multiplied by time. So it says it travels due north, constant speed of 15 kilometres per hour. Really convenient because north just means it's going to be something times j, and 15 kilometres per hour means it's straightforward. It's 15 times by t. So plus 15 tj. Okay, and well, I just tied it up a little bit. So it's 38i plus, and then 16 plus 15 tj. I don't really need to do that, but I just like doing that. Okay, so that's what's doing after 12:30, and then at 2:30, that's going to be 2 hours later. So when t equals 2, Q2 will be, of course, 38i, but then 16 plus 15 times by 2, so 30, 16, 46. Okay, 46j. So that's where Q is at 14:30. Okay. For P, going back to this one, P didn't change its direction at all. So this is what P is doing throughout. So for P at 2:30, the time to use will be 2.5. Okay, and we'll substitute that into, oops, let's just change that. Let's say P, okay, so P is equal to 15 plus 10 times 2.5, so 25 plus 15 is 40. So 40 I, and then 2.5 times 4, that's 10, 36 minus 10 is 26, so 26 J. Okay, so that means that P is there and Q is there. Okay, we've got to work out the distance between P and Q. Let's just do some work in here. So to do that, essentially you're working out what this is first of all, from P to Q. Okay, so suppose P is there, suppose Q is there, you just do it like that. Okay, it's not. Okay, but I'm just giving you a generalization of what to do to find the distance between them. Find the position vector first, or the vector between P and Q, and then find the distance from that. So P to Q, just do vector Q subtract vector P, so that subtract that. All the other way around, doesn't really matter. I've written it this way around, so I'm going to write it as that subtract that. Okay, it's the difference between them basically. 38 subtract 40 is -2, so -2I. 46 subtract 26 is 20, so plus 20J. So you could have 2I minus 20J from Q to P, depends on perspective, whether you're doing P to Q or Q to P. And then what we want to do is find the distance, so that's going to be the magnitude written like this. And for that, of course, you use Pythagoras' theorem. Okay, like here, if that's your vector, of course, you just got horizontal, the I component, vertical, J component, and use Pythagoras' theorem to work out that. So that's what we'll do here. So 2 squared plus 20 squared, and then square root that. So that's 400 plus 4, root 404. It does say give an exact distance, so we don't want to whip our calculators out and work out what it is as a decimal value. We want to keep it as root 404. It doesn't say simplify it, so that will do as an answer, kilometres. Of course, if you do simplify it, you could just write it as root 4 times root 101, which equals 2 root 101. If you really want to simplify it, but you don't, okay? As a value, that's not really that useful because it's an exact distance, okay? But root 101, approximately 10, isn't it? So 10 times 2, 20. Wow, 20 kilometres, okay? You wouldn't call that a near miss, would you? That's why I say you never notice these things. You're there sailing along the ferry, you would never note that there was potentially going to be a collision happening unless the captain was ordered to change their course and direction, okay? Happens all the time, okay? Let that be a comforting thought for you, knowing that you're, people know what they're doing. Anyway, yeah, I hope you enjoyed that question, okay? Hope you got something out of it. Thank you very much for listening, and please tune in again. Bye-bye. No, not quite the end. I think this is an Easter egg if you want, but one that I'm giving to you for free. You don't have to go looking for. Okay. Now the reason I say it is just because I just want to sort of add to that. Okay. I said, look, generally speaking, P to Q, this, but what I don't want is for someone to see that answer and then think, oh, what's happening between? Because of course they don't match up, do they? Remember, I drew that before I knew what this was. Okay. If I do it properly, -2 is going to be that way, and then 20J is going to be vertically upwards. So let's just leave yourself a bit of room there. So -2 and then 20, that direction there, isn't it? So -2, 20, that direction there. Okay, and that's from P to Q. Okay, so if you want to just ignore that one and just, yeah, look at that. Okay, so -2, that's essentially what's happening. Okay, the I component means you're going 2 units east. Okay, but this way. And then west, 2 units west that way, and then 20 units vertically north. Okay, which you imagine because Q was told to start going north, wasn't it? So you'd imagine Q would be further north. Anyway, there you go. I just wanted to address that because I hate unloose, untied, unfinished business. Thank you. Bye. See you again.